Hello guys, good evening. You are welcome to my YouTube channel, the Explicit Tutorials. Please, as you're watching this video, endeavor to subscribe, like, share, and comment, and also do well to hit the bell, that is the notification bell, so that when I upload new content, you will be notified. Please let us go into today's topic. I've already introduced the radioactivity. I've given us all other parts, all that we need in this topic, but we've not treated calculations present in radioactivity, and we are going to be doing that right now. You have a question about, before I do justice to this question about, let me introduce half-life. Alright, half-life. The half-life of a radioactive substance, the half-life of a radioactive substance or radioactive element means the time taken for it to disintegrate, half its original site. I said it is the time taken for the radioactive substance or what entity to disintegrate, half its original what size or mass, half. Now half-life is denoted as what? Capital letter what? T. Alright, not small letter t. Small letter t represents what? Decay time. Now please, half-life is always equals to T over log 2R. Now this T is always equals T over, this R represents what? Disintegration ratio. Disintegration ratio. Alright, this R represents what? Disintegration ratio. Please take note of that. So that is for that. Please, this arrow is also equals to what? 2n. This arrow is always equals to what? 2n. This arrow is also equals to n2 over what? n1. This arrow is equals to 2n. Then it's also equals to what? n2 over what? n1. Now n2 means what? The initial number of atoms. While this, okay, final. This one is what? The final mass. The final mass of the atom, while this one is what? The initial mass of what? The atom. Take note of that. Now this n, you may be asking, what does this n here does not mean number of moles. Alright, n here represents what? Number of half-lives. Number of half-lives. This is equation 1. This equation 1 is 2. This n represents what? Number of half-lives. And this number of half-lives is always equals to T over what? Small letter T over big letter what? T. Small letter T over what? Big letter T. As long as I told us that small letter T represents what? Decay time. Big letter T represents what? Half-life. This is equation what? 3. Do not forget that. Now please take notes. N2 is always equals to N1 over 2 raised to the power of small letter. Oh, let me make it to be bigger. Equals to n over 2 raised to the power small letter t over what? Big letter t. That is what? n2. Take note of that. That is equation what? 4. Equation 4. And again, when it comes to the number of atoms that has been what? Disintegrated, or the number of atoms that has decayed, you say this word nd, right? Nd is equals to n1 minus n2. All right, nd is also equals to n1 then open brackets arrow minus 1 over what? Arrow. All right, as number of atoms decayed is equals to n1 minus what? N2 is also equals to n1 open brackets arrow minus 1 over what? Arrow. I told us that this arrow represents what? Disintegration ratio. Don't forget that. Okay. We'll try again. It also told us, okay, number of fraction of atoms remaining. Number of fractions of atoms remaining is equals to 1 over arrow, and it's also equals to arrow minus 1 over what? Arrow. Arrow minus 1 over arrow. Then now I also have to write 1 over what? Arrow. So these are the formula you need for now, okay? And of course, you know that the decay constants is actually called what? Lambda. The decay constant is what? Lambda. You know that the number of atoms, that is the n, the t, is directly proportional to the what? Number of what? Atoms. Number of atoms. I can also say that the n over the t, that is the time taken, is equals to what? Minus lambda n. Alright? Now, I would have introduced, to eliminate this sign, I have to introduce a constant, which is what? This lambda. Alright? This n is attached because the number of atoms is becoming what? Smaller. The number of atoms is becoming small. That's why there's what? N. Please take note of this. It is very, very important. But in this video, we are not going to be solving question on this. We are going to be solving question on the first ones I gave, apart from this very one. But it's good to take note of this. Now, please. Now, take note that T half is always equals to 0.693 over what? Decay constant. Alright? T half is always equals to 0.693 over what? Decay constant. Take note of that. Alright, so let us solve this question on the board. It said a radioactive sample initially contains N. After three half-lives, the number of atoms that has disintegrated is, now number of half-lives is equals to what? 3. And I told us that R is equals to what? 2N. Excuse me. I told us that R is equals to what? 2N. It therefore means that R is equals to what? 2 raised to power what? 3. Since N is 3, means that N will be 3 here, and that becomes R is equals to what? 8. We've gotten the value of what? R. But they said the number of atoms that has what? Disintegrated. I told you, I remember I told you something. Number of atoms that has decayed or disintegrated is equals to what? N R minus 1 over what? R. If I should put N1, it's everything as what? N. This N written here. Okay? This N is what I have here. Now I got my R to be 8. It means that ND is equals to what? N of open brackets. R is what? 8 minus 1 over 8. Alright? 8 minus 1 over 8. So ND is equals N times, no, this bracket means what? Times. So 8 minus 1 is 7. You now have what? 8. It therefore means that ND is equals what? 7N over what? 8. It means that 7N over 8 is what? Answer. Therefore the answer is what? D. Just follow it step by step. I said that N is 3. R I gave us before to be 2 raised by what? N. It means that N is 3. So 2 times 2 times 2 is what? 8. Wherever you see R, you put what? 8. You are substituting. You don't have it to be what? This. Take note of that. So let us solve another question. I'm going to be reading a question. As I'm reading it, you are writing it yourself because of what? Time. The first one says, are you there? Write it out. Are you there? A radioactive substance has a half-life of 20 hours. I repeat, a radioactive substance has a half-life of 20 hours. I repeat, a radioactive substance has a half-life of 20 hours. Full stop. What fraction of the original radioactive nuclei will remain after 80 hours? I repeat, what fraction of the original radioactive nuclei will remain after 80 hours? Now, what fraction will be remaining? What fraction will be remaining after 80 hours? Now I told us that whenever you hear the word fraction remaining, bring your mind there, arrow minus 1 over arrow is equals to what? 1 over what? Arrow. And I said a radioactive substance has a half-life of 20 hours. Alright, half-life of 20 hours. What fraction of the original radioactive nuclei will remain after 80 hours? Now I gave us that n is equals what? Small letter t over what? Big letter T. Now from the question, they said they gave us a half-life. I told us that half-life is always big letter T to be 20 hours, and they gave us the decay time as what? 80, is it? Okay. Half-life as what? Half-life is okay, 20. Sorry, half-life is 20, and radioactive. Okay, then T is what? 80. All right, 80 hours, and therefore means that N is equals 20 over 80 over what? 20. Right, it means that if T is 80, you put it here, T is what? 20. This to this, so N is equals to what? 4. It means that N is what? 4. Remember I gave you something. I said that arrow is always equals to 2 raised to what? N. So if N is 4, it means that it's 2 raised to what? 4. And this is what? 16. It is 16 because you have it to be what? 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, which means that 2 into 4 places. It is not 2 times 4, it is 2 into 4 places. And say what fraction? You come back here now, F arrow is equals to what? Arrow minus 1 over what? Arrow. That means that 16 minus 1 over what? 16. And this is going to be what? 15 over what? 16. So this is the answer. This is what? The answer. We've gotten arrow as what? 16. It means that whenever you see arrow, you put what? 16 minus 1, then we have 16, then 15 over what? 16. That is for that. Don't you see how simple it is? The first thing you must note is to comprehend the formula first. After comprehending the formula, you now learn how to apply the formula. Now, the next question says, in 24 days, hope you are writing. Right. In 24 days, a radioactive isotope. In 24 days, a radioactive isotope decrease in mass. A radioisotope decrease in mass from 64 gram to 20 gram. From 64 gram to 20 gram. What is the half-life of the radioactive material? What is the half-life of the radioactive material? Of the radioactive material. What is the half-life of the radioactive material? Which means that from the question they said in 24 days, which means that T is equals what? 24 days. Alright, that is for that. And they said that the mass decreased from, which means that N1 is equals what? 64 gram. Then N2 is equals what? 2 gram. I told that arrow, arrow is equals to N1 over what? N2. Therefore means that then it therefore means that 64 over what? 2, and that will give us what? 32 gram. Alright, 32 gram. However, I give us that half-life. Okay, it should be rate, right? Yeah, rate is rate. Now I gave us that t is equals t over log 2 arrow. Alright, log 2 arrow. I gave us that half-life is always equals to t over what? Log 2 arrow. Now this becomes t. Small letter t from the question was what? 24. So 24 over log 2. Now for me to equalize this figure with the base, alright, okay, this becomes log 32 base 2. For me to simplify it further, I'll be having 24 over log 2 raised by 2 over what? Okay, that is log 2 raised by 5 base 2. I think 2 into 5 places should be 32. 2 times 2 4, 4 times 2 8, 8 times 2 16, 60 times 2 32, which means that 2 raised by 5 is what? 32. Then this cannot go out, this 2 cannot go out, I'm left with what? 5. It therefore means that t is equals what? 24 over what? 5. Alright, because log 2 base 2 is equals what? 1. So 1 times 5 is as what? 5. Alright, so it becomes what? 24 over what? 5. So that is what? The answer. The answer is what? 24 over what? 5. We now have another question here. We have another question. After 3 half-lives, the fraction of a radioactive material that has decayed is dash. After 3 half-lives, the fraction of a radioactive material that has decayed is dash. After 3 half-lives, n is equals what? 3. And I give you that r is equals what? 2 raised by n. Therefore means that r is equals 2 raised by what? 3. And r is equals what? 8. R is equals what? 8. R is equals 8. And I told that fraction is equals to 1 over r. It means that fraction remaining is equals to what? 1 over 8. So the answer is what? I give us option here. Look at the option. I give us 1 over 8, 1 over 3, 2 over 3, 7 over 4. Therefore the answer is what? 1 over 8. Just follow it step by step, you will understand it. Alright, let us solve one more example before we call it a day. Let's solve one more example before we call it a day. And we are done solving the questions here. So let's get another question. Okay, I have a question here. Right. A radioactive substance has a half-life of 80 days. Has a half-life of what? 80 days. A radioactive substance has a half-life of 80 days. If the initial number of atoms in the sample is, which means that n is equals what? 6.00 times 10 raised by what? 10. Is that what it is? Yeah. If the initial number of atoms in the sample is 6.00 times 10 raised by 10, how many atoms would remain at the end of 320 days? Which means that t is equals what? 320 days. Alright, the question is, how many atoms would remain at the end? Which means that we are looking for what? N2. Right? We are looking for what? N2. Now I gave us a formula. I said N2 is equals to N over 2 raised by T over what? T. Now N is 6.00 times 10 raised by 10 over 2. Then small letter t is what? 320 over big letter t is what? 80. So this will go into this. Alright, therefore means that 8 divided by 32 is what? 4. Therefore 2 into 2 raised to power 4 is 6 times 10 over 16, because 2 raised to power 4 is what? 16. 8 divided by 32 divided by 8 is 4. So 2 raised to power 4 is what? 16. Now, where's the calculator? Now I now have that. Since we've gotten to this point, we'll say 6 divided by 16. 6 divided by 16 is equals 0.375 times 10. Right? Look, the 10 was here. Times 10 raised by what? 10. Okay, so for we to get the value here, okay, it means that we have 0.1. Let us express this in standard form. We are going to express it in standard form. So we are going to take our point once. Okay, since we have 1 0, it's going to be what? 10 raised by what? Minus 1. Right, 10 raised by what? Minus 1. So it therefore means that we now have 3.75 times 10. Then you now have 10 minus what? 1. Therefore means that you now have 3.75 times 10 raised by what? 9. Alright. So 6 divided by 6.00 divided by 16. Alright, so that is the answer. Alright, that is the answer. Okay. Okay, sorry. This 10 is coming down. So it becomes minus 10. Becomes minus 10. So which means minus 10 minus 1, and that is what? Minus 11. Right, so this is the answer. At this point we call it a day. Thanks for watching. Do have a wonderful day. In our next class, we are going to be solving more questions on radioactivity. Please subscribe and share.